Welcome everyone. In this video lecture, we will solve a GATE 2014 question in which we have to plot the drain current as a function of VSS. Okay. So in this question, a NMOSFET is there, which is a diode connected. Diode connected means it is not given in the question it is diode connected, but basically this one is diode connected in which the gate in of this NMOS is connected to the drain in and this one is our source in. When gate and drain is connected together, it is a diode connected structure. So in this case, we have to plot the ID as a function of VSS. From option, we can also observe that ID VSS curves are given. Okay, and we have to neglect the channel length modulation. So in this case, first we have to think in which mode the transistor is operating. So first thing that we have to think is transistor operation. Okay, transistor operation. Okay, in which mode it is working. Okay, so when gate to drain is sorted, when gate and drain sorted, so it is in saturation mode. Okay, how? I will show you. First, as we know, for saturation, drain to source voltage should be greater than equals to VGS minus VT. Okay, this one for the saturation. Okay, and for the linear region, VDS should be less than equals to VGS minus VT. For more detail, okay, this one is a linear region. For more detail, because we are doing in a step by step method. So as we know the ID and VDS curve. Okay. So ID VDS curve will be somehow linear then saturation. Okay. So this region is called our saturation region. Okay. And this one is our linear region. Okay, and this point is VGS minus VT. So it is clearly understand when VDS is greater than VGS minus VT, it is saturation, and VDS is less than VGS minus VT, it is linear. So that thing I have written here. So it is very important point. So we have to know. This question is very easy, but I am just discussing all the steps, means how we have to think. Okay, so in this case, gate and drain is sorted. So it is diode connected. So gate and drain is sorted. Gate and drain. So we can easily say this VD, or we can write as VG minus VS minus VT. So source one is common, so it will be cancelled, and VD will be VG minus VT, and VD equals to VG. Okay, in this one, gate voltage and drain. So this VG equals to VD. Okay, same potential. So this will be same. So VD will be always greater. So VD will be always greater than VG minus VT. Because if say VD is 5, if VD is 5, for example 5, so greater than 5 minus suppose 0.2 volt. So this 5 will be always greater than the remaining term. Okay, just okay. So you can simply say this one is in saturation region due to this concept. Okay, so if diode connected pair is there, we can easily say this one is a saturation region. It is in the saturation region. So now we have to think about the plot. Okay, so now it is in saturation region, so we have to write the drain current equation. So drain current equation in the saturation region, that is our ID, we can simply write mu n cox W by L VGS minus VT whole square. Drain current in saturation region. Okay, so no need to think about the linear region. So this ID value, this ID, okay, in saturation can be simply, I am writing this mu n cux W by L as a beta, okay, whole term as a beta, okay, transconductance parameter. Then one can write Vg minus Vs minus Vt whole square. Okay, for the time being, I'm writing here mu n cox W by L. Okay, we are just replacing this beta with this term. Okay, so now the drain current ID will be beta and Vg value is nothing but simply it is connected to supply VDD. So it should be VDD and minus Vs. Vs is nothing but simply minus VSS minus Vt whole square. Okay, here I am also writing Vg is same as that of Vd and it is connected to supply. So it is simply VDD and our Vs source voltage is nothing but simply VSS. So it is very important point. So I am again highlighting this one. Okay, simple. Beta we are writing in place of this one mu n c x w l. Okay, so now there is a equation. Okay, id equals to vdd minus vss minus vt whole square. Okay, so if we know the concept of quadratic, okay, so we can easily find the x vertex y vertex. Okay, so for the time being we can write this one as a id equals to vdd minus vs. Okay, so still I am writing the x vertex. So id, okay, id value will be beta. Okay, x vertex we have to write. Okay, so what we are writing, we can write as vdd minus vt minus vss whole square. I'm doing step by step. vdd minus vt one term and minus vss whole square. Okay, so I will go with more basic. So one can write as vdd minus vt. You can directly write, okay, x vertex y vertex, but I am writing with the more fundamental formula plus vss square minus twice ab vdd minus vt into vss. Okay, so now this id by beta one can write. Okay, so it should be a simple quadratic vss square minus twice vdd minus vt vss plus vdd minus vt whole square. Okay, now there is equation in id and vss. So now we have to plot. Okay, so before that I want to find the x vertex. If suppose in a quadratic equation we have to find x vertex. Okay, so here the sum, say y equals to ax square plus bx plus c. So in that case we have to find the x vertex. Okay, in other words simply minus b by 2a. Then for y vertex we have to put the value of this minus b by 2a in the y, then we can find the value of y vertex. Okay, so here in this case the vss vertex we can say instead of x, this one is nothing but simply say y and this one say x, we can say. Okay, but now vss vertex or we can write as x. Okay, in nothing but simply minus b by 2a. So b term is minus 2. Okay, minus 2 and with minus. So again I am writing minus 2. Okay, vdd minus vt is our b term. Okay, minus 2 VDD minus VT beta by 2A. 2A. A coefficient of VSS square is 1, and this 2 cancel, minus minus plus. So should be VDD minus VT. That is our VSS vertex. Now the Y vertex, that is our ID vertex, or in general we can say Y. If we put VDD minus VT in this main equation, okay, so VSS square will be replaced by VDD minus VT square. So I am once again writing VT square minus twice times of VDD minus VT, VDD minus VT whole square plus VDD minus VT whole square. So this whole term will be cancelled. So Y vertex will be simply 0. Or if we beta we can multiply with here. So this X vertex we can say VDD minus VT, and Y vertex 0. Okay. And VSS is greater than 0. So there is a parabola which will open up. Parabola will be open up. Will be open in up direction. I am doing step by step, that's why I am taking some time. Okay, so now, so if you anyone have to plot this one, we can say this one is our ID, that is our Y vertex. I am writing Y or Y something, or no need to write Y, just writing the ID, and VSS in the X axis. Okay, so the vertex will be VDD minus VT, vertex will be VDD minus VT, and Y vertex will be 0. So this one is a vertex of the parallel. So suppose this will be the point. Suppose some point here, VDD minus VT. Okay, and now it will go up. Okay, so it will cut somewhere. Okay, so one can easily find this point when this term VSS is 0. When the term VSS is 0, okay, in the y-axis, that is ID axis, VSS term will be 0. When the VSS will be 0, it will give the maximum value. Maximum value, that is our simply, if we put this VSS will be 0, it will give this value will be sum of beta times VDD minus VT whole square. So we can say this will be the ID maximum. Okay, and when it will there, then at that time this value will be 0. This ID will be ID will be 0 at that point. Okay, VSS is when VSS is VDD minus VT, so ID value will be ID value for this purpose ID will be 0. Okay, for this condition the ID value will be 0. Okay, ID will be 0. So this one is the parabola. Okay, so now we have to think about from the means from the option. Okay, so this will be the correct answer, because ID, this one is the correct one, because ID will be this one, and VSS that is going down with VDD minus VTH. Okay, you can also see VDD minus VTH. Okay, VTH, so going down. So the correct answer, this one will be the wrong one, this one will be also wrong, this one is also wrong, because it not be linear. Okay, it's if this one is like that parabolic, and the whole response, the if in question, it may come like that. Okay, so this one is the actual diagram, but in option this is given like that. So the correct answer for this one will be option number A. So in this question, we have to just think about the which region the transistor is operating, that is a saturation. Then after we have to write the saturation equation, then IDVSS function will be there, then a quadratic equation will form. Then after that quadratic equation, we use the quadratic concept to plot. Anyone can plot very easily. I am just doing a step by step for all viewers, so that's why I'm doing all these steps. So after that you can easily plot. Okay, I'm not a very good artist, so that's why this one is somehow like that. Otherwise, you people may like a better parabola. Okay, id and vss, and this point is our vdd minus vth. Okay, so the correct option for this question, correct answer for this question will be option number a. So any type of question may come from this type of thing, so you have to go step by step solve such type of questions. So thank you for watching this video.